have all seen situations where human life is in the balance. Situations in which a vertical flight aircraft could mean completing the mission or not, and in many cases, the difference between life and death. The ability to take off and land vertically has tremendous benefits on the ocean or on land, where the most direct route is up and over obstacles. Helicopters' forward speed is limited by the rotation of their main rotor blades. Tilt rotors and vectored thrust aircraft also have drawbacks. Clearly, there is a need for an aircraft that can hover efficiently, but reaches high speeds. From this opportunity, X2 technology was born. X2 technology is a suite of technologies that, when applied together, allows efficient hover and acceleration to high speed with no in-flight transition. Rigid, counter-rotating blades, seamlessly integrated auxiliary propulsion, fly-by-wire with advanced flight controls, active vibration control. Sikorsky successfully developed and flew earlier approaches to a high-speed helicopter. Several technologies enabling high speed with efficient hover have advanced to the point that they can be bundled into a technology demonstrator aircraft. With conventional helicopters, the retreating main rotor blade stall limits total lift. As speed increases, a region develops where the blade is rotating away from the direction of travel and no lift can be generated. This region grows as the helicopter's speed grows. At 200 knots and beyond, the blade in this region is stalling. On the other side of the rotor, the tip is exceeding the speed of sound, resulting in a dramatic increase in vibration and power required. The X2 with counter-rotating blades breaks these speed limits. Each rotor spins more slowly to keep the rotor tip subsonic at high airspeeds. The X2 enjoys the full lift potential of the upper and lower rotor's two advancing sides. The full use of this lift potential enables flight at 250 knots and also enables unmatched maneuverability. The X2 aircraft with two advancing side rotors has 1/3 the turn radius of a conventional helicopter, making it more responsive, lethal, and survivable on the battlefield. X2 technology aircraft will hover, land vertically, maneuver at low speeds, and accelerate seamlessly from hover to forward flight. In a high-speed configuration, one or more pusher props are part of an integrated auxiliary propulsion system to enable high speeds with no need to physically reconfigure the aircraft in flight. To demonstrate the viability of X2 technology, Sikorsky has built an X2 technology demonstrator. This aircraft is designed to demonstrate 250 knots cruise capability in a helicopter. Sikorsky's X2 technology demonstrator has made significant progress since its announcement in June 2005. In November 2005, a surrogate helicopter equipped with the new X2 technology fly-by-wire system made its first flight. In November 2006, ground test of the X2 technology demonstrator aircraft began with its LH-Tech T800 engine and drivetrain components. Major assembly of the demonstrator is now complete, and final test instrumentation installation is wrapping up. Ground testing is marching the aircraft through its required acceptance test procedures, ATPs, prior to clearance for first flight. Sikorsky has envisioned applications of its scalable X2 technology in a wide range of missions, such as combat search and rescue, armed escort, and missile site support. In an escort role, imagine a situation where an enemy aircraft is spotted. In this time-critical situation, an armed X2 technology aircraft can engage and destroy the enemy to allow the mission to continue successfully. In combat search and rescue operations, downed air crew rely on the speed of the rescue helicopter to get them out of harm's way as soon as possible.
Bail out! Bail out! Bail out! Scramble Jelly 1-1 and 1-2. ETA to target, 22 minutes. Roger.
In the same context, the SAR aircrew rely on the speed and agility of their aircraft to get them to the survivors and back to safety.
Home plate. Survivors on board. ETA 30 minutes.
X2 technology can also play a vital role in protecting the nation's assets from attack. Speed and the ability to take off and land vertically are vital to enable access to locations not available to fixed-winged aircraft.
DRF scramble. Intrusion code 1 alert.
Say 2223 en route. ETA 35 minutes.
Say 2223, have target in sight. Deploying TRF. Suspects get ahead.
Sikorsky has envisioned applications of its scalable X2 technology in a wide range of missions, such as search and rescue, medevac, armed escort, anti-submarine warfare, and anti-surface warfare. No other mission relies on the unique abilities of a vertical lift aircraft like search and rescue. Imagine an injured fisherman is 150 miles offshore. An X2 technology aircraft with its excellent low-speed handling and low downwash can rescue a person and bring them to treatment far sooner than conventional helicopters. The distress call comes in and the aircraft is launched. It arrives on the scene and hoists the injured fisherman into the aircraft and safely brings him to a land-based hospital. In another scenario, where enemy surface or subsurface forces threaten the battle group. In this situation, an armed X2 technology aircraft can engage and destroy the enemy to enable the battle group's mission to continue successfully. X2 technology-equipped aircraft are ideal for sea-based missions that require speed and maneuverability. Greater speed, flexibility, and agility translate directly into more rapid and efficient tactical mission area coverage. An X2 technology aircraft greatly improves the Navy's ability to detect, localize, and engage potential threats at increased range. Its adaptability and fit with current and future seaborne platforms make it a superior, mission-ready force multiplier. Sikorsky envisions X2 technology aircraft can support or perform insertion, attack, escort, and enhanced company operations missions.
99 aircraft, clear to launch LSC signal, contact control.
In the sea-based insertion mission, the X-2 technology unmanned system interfaces with an airborne command and control aircraft to identify, engage, and suppress a threat.
Shooters 1-1 and 1-2 inbound for your control.
We have 2 ZSU 23-4 and 18 troops in the vicinity of objective. Shooter 1-1 engaging. BDA as follows. 2 ZSUs destroyed, 15 KIA, 3 troops observed departing to the north.
With the zone secured, the Marines begin operations. X-2 technology aircraft speed and maneuverability make it ideal for the escort mission. In this scenario, up-armored Humvees are external to their objective, but the CH-53 Kilo heavy lift helicopters
99 aircraft, we have a leaker bearing 340 at 22 Angels 10.
Tally Bandit at 11 o'clock, engaging.
When an airborne threat emerges, the X-2 technology armed escort aircraft swiftly intercepts, engages, and destroys it.
Bandit destroyed.
Upon reuniting, the X-2 technology aircraft provides air cover, while Marines set up a security perimeter. Technology armed unmanned aircraft will also support sustained ground operations. Imagine that the platoon takes on small arms fire.
Taking small arms and RPG fire, 300 meters north of my position. Clear to engage, my mark, my control.
Coordinating with the airborne command and control station, the Marines on the ground call in air support.
Engaging. BDA as follows. 15 KIA, 0 remaining.
Request immediate resupply. Resupply mission en route. Passing control.
With the area resecured, the Marines on the ground can be quickly resupplied from the sea. The ability to perform this mission in an unmanned mode will allow the Marine Corps to reduce the need to place troops in harm's way and provide greater flexibility to deploy Marines where they are needed most, where their skills are in greatest demand.
Mission complete.
The X-2 technology stands ready to support every mission. Just imagine, what can X-2 technology do for you?